paper written by your advisor in Google Scholar, right? You know how to do that with author, find all the papers written by me, published in some place in past 5 years, right? So Google Scholar makes it easy to do these sort of narrowed down searches, which is part of the thing that can be pretty helpful. So some things about searching though, and I sort of hit on a little bit about these. Come on. Searching can be weak, and it has this sort of implied connection between words. You gotta be a little careful about doing it. So you can use plus to get common words, quote to search for a particular phrase, minus to get rid of them. Author, in title, this is one I didn't mention, but if I want to search for the word to be in the title of the paper, I can say in title, and that'll search only within those. And all that stuff's on the advanced search screen, so you can sort of go through that. The one thing about trying to search in particular documents, the sort of source, is you have to know how the source is represented. So normally I search for some things, find how the sources that I know would be in there by using searches, and then use that to refine it. As I mentioned, you can find all the papers that cite a given paper. You can find related papers, and again, that's very important because, as I said, our lexicon may not be what everyone else in the field uses as a lexicon, and you really don't want to submit your paper for publication and then have someone say, really, this is just the same as that, and those guys published that 3 years ago and you didn't compare, and that's it, your paper's done. Because they think that paper's better than yours and you didn't compare, and so you got to figure that out. So, and we have had in my lab in the last 3 years at least 2 or 3 papers where within 2 or 3 days of submission, I found another related paper, right? And then we like frantically rewrite stuff to address it. And it's tough because even though I've been doing this for a long time and I go through a lot of this process, there's just thousands of papers and sometimes it's hard to find ones that are relevant. But yeah, with this process, you can literally get to hundreds of papers in under 5 minutes. Okay, so the assignment, your next assignment after this would be 60 or 70 papers, right? People are like, how can I get to 60 papers? It's really easy to find 60 papers that are weekly relevant. The next thing is you got to decide which ones are really relevant, right? And that's going to be later. For now, we're just going to start with you finding enough papers to fill in your thing. Now, the one thing I didn't mention, so I want to go back to. Where'd you go? Escape. Escape. Come on. Oh, my Chrome window went away again. Dang it. Okay, so there are 2 things that are, another thing worth mentioning that I forgot was this My Library. So when you're doing these searches, right, it's really, you want to keep track of what's going on. I'm going to show you 2 different ways. So one is to click on My Library, right, and if I have, so now my library is enabled. It's over here. I'm in My Library. So these are papers in my library. I use My Library as a place for me to bookmark papers I want to read. Don't always get to it, but I bookmark them. So when I'm doing my regular search, if I click on star, I'm now adding papers to my library. Not very hard. There's another thing I wanted to show you, which is, so when we go to use citations, we'll go to that in just a second, right? So I can actually click on the double quotes and it'll give me citations. One of the things I can do is get to BibTeX, which we'll use for LaTeX. If I go back up into settings for my Google Scholar, there are 2 things here worth noting. So I can click on show import links to citations in BibTeX, which I'll show you in a second. That makes it a whole lot easier to get them in. I can tell it how many pages, things I want per page. I can tell it if I want to include or not include patents or case law, how I want to handle the windows. If I go over here, there's 2 other things that are, save. You have the cookies on, so I may not always remember to save those. If I go back to my settings again, there is your library links, right? So in here, if you type in University of Colorado at Colorado Springs, whatever, right? And then you go searching for it, it'll look for our library. And if our library is listed, then when I go to do searches, it's already in there for me, it will show me for some things. Let's just do, like this one here says full text at UCCS. Now, in this case, because I'm actually not only telling it to look at UCCS, I'm on UCCS's campus, which includes using it through the VPN. So if you VPN to campus, or if there's actually a whole page in the library how to set it up, right, then I can just click on this. This link is not free. It's free to use as a student at UCCS because we have subscription to that particular organization. But even if it's a place where it's not free, it'll show me full text ad, and then I can talk about how I would get that. So, and that can be very useful because now I can just click on, right, this IEEE link or this Science Direct link, which is Elsevier, and just instantly get into those various papers. One last thing in your settings. So you can actually add a Scholar button in your browser, which will basically let you go search for, you take some string like when you're in a PDF of a file, but only within the browser, and then click on it, and then it'll take you to look up that up in Google Scholar. A little bit useful, but it's that little guy over there. I still use it. And then, so you can, when you play with these off-campus links, you can set them up so that when you're off-campus, it will not show you stuff you can't get to, because sometimes it's really annoying to see all this stuff you can't see. You only want to look for things you can actually find, so you can play those. And all of this stuff is available only when you're signed in, so if you don't have a Google account, you can make up a new one and use that. So, any questions on those? So all that can make your stuff a little bit more useful. So I'll go back into PowerPoint. So the one thing, if you download more than like 100 papers, if you go through more than maybe 10, 20 pages of Google Scholar too fast, as I said, it'll tell you it's a robot. Slow down how fast you're going, right? So if you're looking for something, if you do get locked out, I have found that switching to, for example, be on campus for the VPN versus where you were, and starting a new browser, maybe an incognito browser so it doesn't match stuff, right? Will allow you to continue searching. So I will sometimes do a mixture of different things. They do IP matching and some browser cookies, right? So there's a balance in terms of what it takes to, if you want to search through hundreds of papers really fast. A couple of other things, which is not obvious until you start doing this a lot, which is you will actually get different results on somebody else's computer. For a while, the Google Scholar team intentionally did not use any of your other search history, but they found by various testing that lots of people liked using your search history. So your order of search list and my order of search list for exactly the same words will not be the same. Right? It's based on my history. If you want to get a less biased view, because you have a very biased view of the world and what you've been searching for, open it up in incognito, and you'll get less biased, better results. You'll see different things than if you just keep searching. One of the things I forgot, which I'll go back and show you now, you can actually set up an alert to any paper that is key to stuff you're writing about. And as I said, one of the ways we found, we had like 2 or 3 days before something came out, a paper that we had cited, we said to give us an alert anytime somebody cites this, somebody else cited that, and then we went and found their whole body of work that was completely different from what we. I did not close that Chrome browser window. Okay, well, another Chrome. But this can be useful. We're going to Scholar. So, by the way, if you've set up and you've got searches and preferences, it'll send you like all recommendations. So use all the paper in the last couple of weeks that I have not yet gone through that Google thinks I should look at. They will actually send me this by email, which they do all the time. And it's good because if you're not paying attention, you can get to that. So over here, there's this button that says Alert. Click on Alert. And so you can sort of see I have 2 standard certs. New citations of my articles. Anytime somebody cites me, I want to know about it. Because if they think my papers are relevant, maybe I think theirs are relevant, and you know what's going on. And then this other is a particular paper, adversarial examples in treating properties of new works. Both of those are sort of interesting. Just to sort of read over. I told you, like, you have to be able to read a lot. So my profile. This is me. This year, I've got 600 citations to my work, which means 600 papers have been emailed to me to go look at, right? Just to keep up with people who are citing my work and I'm small potatoes compared to some of the bigger names in the field. And if I go back to particular papers, like that particular one, right, adversarial examples, right? This paper has 2,800 citations in the last 3 or 4 years, right? So I get like 50 or 100 of those citations like every other week. I get a whole bunch of them. The last thing I wanted to mention is there are particular people, like if you're doing adversarial machine learning, actually for adversarial machine learning, this guy's probably better, good fellow, right? So he has this is his profile page. You can sort of, the original GAN paper, right, 10,000 citations, right, ridiculous numbers. You can actually follow people, and then this is different than following a particular article. You can actually, every time they publish something new, you will get information about their citations. So that's a good way of keeping up. In a field that's turning over so fast, if you have to remember to go pull information, it's easy to fall behind. So I do recommend in your core area, choose a couple papers, get updated anytime somebody cites them, so that you know that paper was relevant to me. If other people are citing it, I want to know about their work right now. Right? Because it can be the difference between your paper being accepted or not accepted if you recognize you've been missing some stuff. Somebody else said it. That's how we found one of the papers for our NERPs. They cited one of the papers I cared about. I went and looked at their work. It's like, wow, they don't use any of our terms to describe their problem, but clearly it's relevant, so I have to find it. The other one we found is because I go through almost every paper in the last year's conference of a conference I'm submitting to and say, is that relevant? Is that relevant? Is that relevant? In a very quick scan. So you go through this stuff fast. So enough of Google Scholar. Over here, in case I want it later. And so now the rest of today's agenda is I'm going to switch over and I'm going to look at two tools. The first is Zotero, the second is LaTeX. Zotero is actually really quick and simple, and I will then get into LaTeX since two of you already knew that. I'll do them in that order. So Zotero, well actually I guess I have slides in place. So I'll go to my slides. Okay, so I'm actually going to look at, this is actually an example of what's called a reference management tool. And these are tools that help scholars manage lists of references for research projects. For those of you who don't know LaTeX, I assume that means you've been publishing like using Word, right? Or not publishing, but these tools are actually way more important for people who use Microsoft Word than they are for LaTeX. LaTeX uses a simple representation, but I still find these tools useful. If you think I'm going to use LaTeX, I'll never use these tools, I still recommend you use them. You'll see why when we get through all of this. If nothing else, because whenever you do a project, somebody does Word, you can integrate it more easily. But also, it's nice to have a way of organizing your stuff. So there's a couple of them that are free. The two best free ones are Zotero and Mendeley. The subscription ones, Ref Manager, EndNotes, RefWorks, ProSite, these are all things that, in fact, only two of them even work with LaTeX. The others are just Windows, just Word. Campus has a reference license for one of them. I don't remember which one, but I always remember that. RefWorks? Okay, yeah. So it's like, I know they had one. It's like they've changed once, but it's like, I don't care. They're like, don't you want to use this? It's like, no. Zotero's better and it's free. So it's free, open source. It's available as an add-on to the Firefox web browser as a web browser. There are standalone versions for Chrome, Safari, and Firefox browsers, which is really the way you can do it. And for both Mac and PC, there's actually a nice integration, which I will actually show you some examples of. So www.zotero.org, and you can get started with using it. So Zotero recognizes bibliographic information on books, journal articles, puts them together. The reason I like it, and I have found it useful, and a bunch of my students have as well, is it can actually store related PDFs, files, images, and links from your library. So not only do you have the reference, you can actually have the PDF of the paper with it. So you can keep them together, which is both good and bad, because after you go through a couple hundred papers, now it's really big. But you can actually store it all on their servers, not yours. And so they can do it in a mixed way. But it'll create a bibliography for Word or LaTeX, or export a bib file for LaTeX, and it will allow you to sort of go between them. And you can keep track of a large set of them. And you can publish shared libraries for your organization, class, or research group. And this is the other place it becomes useful is somebody else has references. You can say, oh, let's merge our references list and get a bigger list of what you each think is interesting. This is actually an older slide, but it's like Zotero 7 or whatever. But on this page, you can download Zotero for Mac and a Zotero connector. There's a Zotero for Word. There's actually, I think, even maybe now a Zotero for Linux. The standalone versions work pretty well. So on Windows, there'll be like a little Zotero thing down on the bottom. And on a Mac, you end up getting something as well. So to use this, you actually open the standalone version first, and then you start. Then it'll interface with your browser. So there's a Zotero plugin. In fact, if I go back to for me, this little icon here says Save to Zotero, Google Scholar. So you won't see it, but I'll go over here. I'll fire up my Zotero. And now, go back to an actual search. I'll just click on this. Related articles. So now I have a bunch of papers. So if I click on this little thing here, it'll show me which items do I want to add to my reference. So I'm not going to actually click on any of these, but I can go in and click on any of these. And any of them that have, when I click on them, if it has a PDF listed over here, it will import that PDF into Zotero so that later on I will have them. I do a lot of work where I work mixtures of online and offline, so I'll do a bunch of stuff online, get in a car and drive up to the mountains to go skiing, and now I have all the papers with me. I don't remember which ones I downloaded. And it keeps them together. And then inside of Zotero, there are actually some search functions. So once they're in, you click on that, you register. You don't have to register. So when you click on them, you can import citations for a single item. I can click on a whole bunch of them. I can automatically add web pages. So this is the other part that makes Zotero. Today's world has become far more multimedia oriented. So you might actually have a blog post. Like the other tools, I don't think RefWorks can import a blog post, right? Doesn't know what to do with it, but if it does, maybe it's improved. But the NWorks did it before. It'll include like, here is the web page, here's the URL, here's the data associated with it, and it will save an image of that web page. Especially for web pages, which change a lot, that can be very useful. You can also search for things by ISBN, DOI, or PIMD if you have those to search for them. Inside of Zotero, it actually understands there's a little button for different types of references. So I can make one up and type it by hand. Don't regularly do that, but there's a reason I will do that, which is if I go back to the example I had going. So if I go back into Google Scholar, let me choose one where I know the answer. So this one, I don't know if it's going to have it or not. Something okay, I'll just do it. So if I look at some of these, conditional generative nets, right? This paper, if I import it into BibTeX, right, it'll give me a BibTeX file and it'll say archive preprint because that's what it shows up as. But if I click on all 4 versions, well, this one doesn't. A bunch of papers that are in archive will also be someplace else. They've been trying to clean some of it up, but there's still 4 or 5 different versions, but some of them will actually be published in a better place, right? So then I can go in and fix them up by just choosing the right thing to import. Others, however, even if I import them into Zotero, they will simply be garbled because something went wrong in the import, wherever they pulled the R thing off of. So inside of Zotero, I can go in and I can choose something, and I can say, okay, it's a conference paper. I can edit any of these fields, and then Zotero knows what those fields mean when I go to make a bibliography. So I can fix anything that's broken. So if I find one that was in archive, I can go in and say, okay, I will fix this one. The other part I will see is like when I first imported them, they might have been unpublished in an archive and they don't get published. So you want to update stuff. So Zotero makes it easy. You update any of these things, and then you can continue on with the process. So you can type them in. You can fix. You can put a title, fill in whatever you want. If you're doing PubMed, which none of you are probably doing because none of you are doing medically related stuff, a separate menu comes in so you can sort of save them. I have no idea why I have this slide in here. Oh, just to sort of show you, like if you go to import something and Zotero's not running, it says like it's not running, fix it. Select the ones you want to import. And you can set up a bunch of things when you go to import them. Attach a link, attach a copy. So these are some parameters you set up when you start doing your imports inside your Zotero. Mine, I don't have it stored copies anymore because they were just becoming too big. I import way too many of them. But I do actually ask it to attach a link to the URL, so when I go find a paper, I can just click on it and then go back to where the paper was. So I don't have to do all the searching again. You can build subdirectories, which I think is what I'm showing here. So if you have them, there are two things you're going to try and do. If you're working in, one way you can do it is just export it as a file, so you can save it as an RTF file or HTML file. Or a BibTeX file, so you can tell Zotero to export it. If you work in Windows, so I can select a bunch of references, right-click and say create a bibliography, which it will then choose a set of them, and I can know what to do. But more importantly, if you're working in Word or OpenOffice, both of them have support, you can basically bring in a plugin that integrates with them, and then you can insert a bibliography, edit it, add some document preferences and refresh it. And most importantly, you can add a citation. So you go somewhere in your Word document, click on it and say, insert a citation here, and it will take care of all of the formatting. At the end, you say insert bibliography, and it'll insert bibliography at the end. These other things like preferences, whatever, say, do I want IEEE, ACM, APA, different file formats. In Microsoft Word, if you've installed it, then there's a little Zotero up here that lets you mess with the things you're going to show. I already explained what all of those were. So the one thing that's a little bit odd is if I want to insert multiple, like, as you've seen in papers, there's like square bracket, paper 1, paper 2, paper 3, and square bracket is a common citation style. You do that in Zotero by clicking multiple sources, and then you can insert multiple things all at the same time. You'll get, at the end, Zotero will have a thing. If you don't want them formatted this way, you have to go in and change the properties. Don't directly edit anything that Zotero installed in the document, because when it refreshes, it'll break it. You edit stuff by editing the Zotero version and then reinserting or re-updating and refreshing. It has a whole bunch of styles, APA, Harvard, IEEE, Vancouver, a whole bunch of things. There's even more. If you want something special, go there and you can import a new style, just like you can import a BibTeX style. So you go into their style repository, say I want this file format, click on install, you get a new style format. With a web account, through the Zotero web account, which is free, and they maintain storage, at some level, if you get too big, they'll make you pay. And then you can synchronize your local version and the web version. This is very useful if you are sharing with, say, your advisor and you want to share references. It makes it one way of sharing. Here's a whole set of my references in and out. So you set up your library. You can have multiple different libraries, and you set them up. Okay, so that was Zotero. Any questions? You don't have to use it in this class. I don't care. I will never ask you again if you've used it. It's up to you. It's a preference. I will say you have to use LaTeX, and I will show you 2 ways of using LaTeX. The first is this, overleaf. I'll actually sort of show you some overleaf stuff, because I'm going to link it into what we're doing with Zotero, which is sort of why this slide will appear. So if you're using overleaf, which is one of our LaTeX tools, and Zotero, you can actually click inside of your overleaf account and say link it to your Zotero bibliography. And now when I'm doing things in overleaf, it'll automatically pull from my web version of my bibliography, and I don't have to worry about having separate files and keeping them all up to date. So if you have lots of files and things working on it, it actually helps simplify your process. A little bit more learning for Zotero. There's a whole bunch of screencasts and videos you can watch and sort of make that work. So you can, this one was here because you can actually set up your own file to do web dev based syncing if you really want to go that far. Now back to LaTeX. So we're going to start with generals of LaTeX and then we'll get back to overleaf and stuff. So my introduction, this is taken from not so short introduction to LaTeX. There's whole books on this. LaTeX is a formatting system. One of the reasons I want you to get to this is when you work in your first papers, you don't need LaTeX. You're doing 6-page paper, you can do that in a typewriter if you have to. But when you get to a thesis, your final thesis, the average thesis has 6 chapters, 2 appendices, 14 sections, 18 subsections, 196 charts, dozens of figures, lots of cited works, right? You want something that makes managing a document this large well. And Word is not that tool. I've actually helped 2 or 3 people in other departments who were struggling as they approached their thesis due date, and their thesis started doing really crazy things. They started putting all their chapters together, and like one little change, and the entire document would blow apart. Remember, Word is just not designed for very, very large files. Or for LaTeX, it's designed for doing books and theses and big things. So it's very effective. I did my entire thesis, which was 380 pages, on 2 floppies using LaTeX, right? Back in the day, right? Because back then a laptop with 2 floppies was a big deal. Right? Now it's nothing. But, data for a thesis, if you have a big thesis in computer science, you might have something with 40,000 raw data files, 8,000 process data files, charts, tables, a bunch of things that go wrong. One of the things I strongly recommend is you develop a publication process that tables and charts change when data changes. And in fact, I recommend that the way you deal your thesis is you say make thesis. Right? You use make, this tool we use for software. It is a tool for automating stuff. You can literally say make thesis and it will rerun, if it's set the right dependencies, it'll say, oh look, this data file has changed. I need to recompile the Python to generate the figures to include in the LaTeX to make your thesis, right? And everything stays magically in sync if you've taken the time to set it up. And the CS people dealing with those kinds of scripts make stuff. So you have to have scripts in Python, shell script, awkset, BEP, whatever you want to do, to generate process data, generate figures. Non-interactive programs, if you have to, Matplotlib, GNUplot, whatever, to generate some charts, right? I don't recommend you do all of your figures in PowerPoint and Excel, right? You can do some of them that way. Why? Because when you're really focused on how to make it really look pretty and you want to do it exactly once, do it, right? But lots of your stuff, if it's generated from data, it should be generated from data automatically, right? And so coming up, it takes a little bit of time to get started, but then it's like, oh, I've made one change, I want to go redo it. And you can actually, both Matplotlib and GNUplot, MATLAB, and LaTeX can all generate arbitrarily good graphics. They're programming languages, they're Turing complete, you can do anything you want. That's how hard it is. And if you really want to say, here, I did it in PowerPoint or Illustrator or whatever, it's actually good to have some really nice graphics every now and then, a couple of them. But those should be symbolic, idealized things, sort of teaser figures, things that are generating ideas, not actual raw data. If it's raw data, use a program. Integrates with other tools, automated formatting and numbering. The other reason I really like LaTeX, because I wrote my thesis, that was me. Right? Now when I'm working with 8 people on one paper, right, LaTeX is actually a tool because it's line driven. We'll see a little bit more about that. LaTeX plus Git get along really well, and I can have 8 people editing the same file. If you've ever used Word or about integrating multiple people editing at the same time, with LaTeX, you sort of choose what you want to typeset it into. So I can easily make a couple changes and go from one file type to another file type to HTML. And in fact, if you really want to play some funny games in LaTeX, these are all things generated in LaTeX. Right? I can generate table of contents. I can generate like derivation trees. I can do all kinds of nice math, which is actually why a lot of CS stuff goes in it. I can even do drawings. I can import figures and do all kinds of powerful things. So you can do a lot with LaTeX. As I said, LaTeX is actually Turing complete, and one of the larger projects I worked on many years ago. We built a documentation language that allowed us to take our documentation for the classes we were working on in a large class library, and we compiled the LaTeX source to generate the C++ headers and stubs for our code. Back when in a day which is not as much popular, there's this thing we talked about, it's called literate programming, where we wanted to make sure our code and documentation were always in sync. So you change the documentation to get a new function. You want a new function in your class? The only way to generate in our tool chain was you documented it, and then you recompile the LaTeX documents, and it generated the stubs for the code to make everything work. So, you can do a very lot of powerful stuff. So it's not uncommon to have a root file, some multiple sub pieces. Your paper in general, our general structure for paper is at least 5 pieces, separate files, plus figures that are generated in various ways with scripts to generate like a tab.txt for a table, or a figure which gets generated from GNU-plot or matplotlib, where code generates all this stuff. And then literally, you go to the main paper directory and you say make paper, right? And it goes off and does stuff. There's a bunch of resources. A great place is CTAN, the Comprehensive Tech Archive, which is good for packages and tools, which has tech and LaTeX. Lots of information on both the TUG and the LaTeX project page. There's a couple of video tutorials. LaTeX is actually quite complicated and very powerful. Knuth invented this in the 70s and kept developing it through '89. He really wanted decent typesetting by the authors, really pushed the I want to have scientists publish their own papers. The same output now as in the future, so things didn't change a lot. Low level but powerful, and sort of frozen in development. Knuth stopped working on it. He actually had a bug bounty for a while. You could get paid if you could find a bug, but it's actually a pretty small and compact program. LaTeX, which is what most people are using now, came from Leslie Lamport, and started in the early 80s and became very popular by the mid-90s. It's actually a bunch of high-level macros written for and in Tech. Tech is a programming language for document setting. LaTeX is just a bunch of macros on top of it, which is designed to be extensible. The current version, I think, is 2E. It's moderately easy to use, moderately difficult to extend, depending on how good you are at understanding tech. So there's a whole book on writing code in tech. Some people say LaTeX, LaTeX, LaTeX. I don't know what matters. According to Knuth, you say tech as in Bach, so it would be so you'd say LaTeX. I say LaTeX, but it's not latex. No matter what you say, it's not latex. Lamport says whatever. I'll make it. Getting started, you need a LaTeX installation in any major operating system, including Android. You can get a LaTeX installation that will install a bunch of stuff, a bunch of tech tools. In fact, most operating systems have multiple choices. And given the right installation, assuming that's all done, then you have a tech file that has things. In general, you almost always have some external files, some editor, a tech editor, BibTeX, to make things. So the most common packages for Linux are something called TechLive. For Mac, you can actually get TechLive, which is what I run. There's also a MacTech and a MikeTech and Tech Tools or something like that. So whichever one you're comfortable with. I don't like GUIs. I don't like anything that makes me touch the mouse or the key. Right? I just want to keep my fingers on the keyboard. So I don't like most of the other tools that are designed for people who want to click and have GUI things. So don't take my recommendations. I live most of my operating system work is done in Emacs, which is an editor old enough that nobody will ever use it. A tool which is very common and what you will use for what you can use for this class. I will actually be fine if you use raw LaTeX, but in the beginning, lots of people find this useful. And I have found that many of my students like this for working on a shared document because it makes seeing edits, so it literally is an online web-based editor. When you're editing documents, they will be updated. So you'll literally see the other person's typing like you would in Google Docs or whatever. And because of that, a lot of people like it. I will show you that in just a second. Overleaf is, there were two, Overleaf and Share LaTeX. Now Overleaf bought them, so there are just one. There's a couple of other places. especially if you wanted to integrate tools. So there's math tools in Quick LaTeX, both of which will let you do math in LaTeX. If you're forced to work in Word or PowerPoint, which I often, unfortunately, am, because my sponsors say, you will give your presentation in PowerPoint tomorrow. And it's like, okay, so I take my LaTeX stuff and I turn it into figures. Right? I can do that by producing a PDF and sticking it in a screen grab and sticking it in a file. And then there's some tools that will do that kind of stuff for you automatically. So, Overleaf is a web and browser-based LaTeX editor, cloud-based storage, large number of templates, and it's a collaborative document environment. So if you sign up now, you can have free accounts and you can have paid accounts. Right? Their entire freemium model is to go expand. As a student, when you get a free account, you'll actually be able to link it to mine. I'll actually send out email links about how to do that over the next week or two, which I think will give you more storage or something because you're in a class where I'm using it. Other than that, there's not much real difference. Oh no, I think once you're in a class that I'm using it for, it changes the Git interface to make it just a little bit more flexible. Paid accounts have a much more powerful Git interface than the free one. You'll get something in the middle. So Overleaf, after you start up, there's sort of a directory of file structures over here, the LaTeX source code, and the rendered, here's what you get when you click on the image. And then you basically can compile it. Inside of their project, when you go to make a new project, you can choose a template. So you can choose IEEE, ACM, AAAI. They have a whole bunch of templates you can get to. So where can you find LaTeX? I think I already mentioned all these guys. So making your first LaTeX document, you will be making one for this assignment. So you're going to start with a skeleton document. You can find skeleton documents from almost anywhere. You can find a template. Templates come with style files. So part of this first assignment, I'm not going to go through all the details. You're all PhD students. You can muddle through figuring out how to put together a piece of software. So you're going to start with skeleton, write your stuff, annotate the appropriate parts, put into math, interpret through the appropriate program, fix errors, modify, and try again. If you get a LaTeX error, how do you think you're going to resolve? What does this mean? Because I guarantee you, you'll get errors that make no sense to you unless you understand how it was implemented. They're sort of like compiler errors. What do you do? Google it, right? Just take the error message, stick it in Google. You're not the first person who's had almost any error that has ever occurred, right? They will find you some answers and you can move forward with that. If you get some really weird behaviors, and we've had some people get really weird behaviors, feel free to ask me. I am a bit of a tech expert, so I can help you with lots of things. But try Google first, because if it's really obvious. I will gladly send you the link that says, let me Google that for you. If you've not seen those videos, right, it'll just play like how to type something in Google if the answer is that obvious. But, yes?
I was going to say that one thing I've noticed for Overleaf versus like having a native LaTeX compiler on your computer is that when you go to find errors and you go to search for them and like Stack Overflow, it depends on where you're compiling LaTeX. Because Overleaf has one way to address that particular error compared to the compiler you might be using.
Yeah, so there can be, well, so in fact, so when you find an answer on the internet, right, it may or may not apply to your environment. Same is true with code and everything else, right? So if you're getting an answer and somebody's saying, well, I'm using MikeTech, and you're personally using Tech Live, right, it still may not apply. So it's the same broader version of that, right? So the environment within Overleaf is not necessarily the same as other things. So you have to understand what's driving it. So when you're dealing with LaTeX is a lot like, in fact, LaTeX is a macro structured language where I have slash, the name of the macro, and then arguments show up in squiggly braces. Required arguments show up in squiggly braces. Optional arguments show up in square braces. So this has got like a bunch of packages. Here's an argument to the author command. Here's an argument to the command date, which takes the command today, right? They're actually all just a bunch of low-level commands walking through. When I compile that with LaTeX, it will produce, depending on how I compile it, a file.out, a file.aux, a file.log, and a file.pdf. In this case, it compiles a PDF because I used PDF LaTeX. Otherwise, it might produce a file called DVI, which is the device independent viewer, or a PostScript file. There's lots of output choices. HTML, depending on what I compile it into. The log file has a log of what happened during the process. Aux file has a bunch of auxiliary information, like what was cited, what were the section numbers and stuff. And then the file.out has a bunch of other information that may or may not be useful. Core structures. beginning of a document, / document class. What class is this document? Some optional arguments. This says make it 11 point instead of 12. Use 2-column format of article. Use a package called AMS Math and a package called GraphicX. Begin document says this is where the document begins. Everything else above that is called a header. Some stuff to fill in, and then end document. In the environments within LaTeX, begin and end are matched pairs that take a squiggly braced environment name, and they have to match in that pair, right? So if I have begin document, I need an end document. If I have begin itemized, I need an end itemized. One of the very common errors is if you forget one, or for those of us dyslexic, if you misspell one. So you have begin itemize and end itemize without an I, right? Then the itemize isn't ended, and your document will say end within group level 1 of itemize, right? And the line numbers that it'll tell you, just like the line numbers in compiler errors, don't always match up, right? So you'll have to dig around a little bit. So where it's going. Command generally start with the backslash. One thing that many people have been confused about with LaTeX, so it's important to understand, which actually comes from tech, is that LaTeX gobbles spaces, and any number of spaces collapse to 1. So if I want to say 1 with a bunch of space followed by the number of 2, I can't fill in it with spaces. I can fill as many as I want, and it will be 1 space 2. Right? In fact, the spacing between 1 and 2 is actually based on what's called blue, so it's not even a fixed spacing. So if I want to have spaces, I have to understand the rules for spacing in LaTeX. So I can use / backspace and a bunch of other things. The other part that's confusing is if I use a command like / begin document, any amount of space after this document, right, will be eaten, right, until the next non-space character. So it doesn't have white space before your first character of the file because the command begin document ate it all. So that's sometimes very confusing. % start a comment, and it goes from there to the end of the line, which is interpreted until the next carriage return in a Linux file and the next carriage return line feed in a Windows file, even if you've moved them across platforms. So you have to understand where they're going to go. But most importantly, if I say, and this improved the performance of the system by 7%, it will eat from there to the end of the line. So you have to say 7/%, which says interpret the next character literally. There's a lot of functionality, images, equation, links, and whatever. A bunch of packages. I'm not going to go through them all, but there's a whole bunch. LaTeX has a way of doing things like make something bold, text BF for bold font, make something italics, text. You can actually do text IT or emphasis. Emphasis is preferred because LaTeX actually has a nested concept of emphasis, so that if I have emphasis inside of emphasis inside of emphasis, it doesn't just keep saying they're all italics. It actually changes, so it'll use different subfonts so that I can have differentiated things inside a quote that might have italics that inside of something I did with it. You can do underline, you can play with the sizes, you can do large, larger, small. Notice these two are actually different. The text BF takes things as an argument. Env takes things as an argument, but large is inside a set of squiggly braces. Large actually says change to a larger font until I tell you otherwise. By putting it in the square braces, think of this as an environmental block in C code, right? It changed until I leave this code block, and then it goes back. And because of the more obscure rules of LaTeX, of tech actually, if I do large before a table, it doesn't affect the stuff inside a table. Tables have their own fonts, and you have to mess with them separately. As I said, many spaces is 1 space. Use // for a new line, but I really encourage you to avoid adding new lines. LaTeX is designed to do the proper formatting, so if you're trying to beat it into submission, don't. Right? Let it do what it's supposed to do. The only time I do that is when I'm trying to write something where it wants to make something and I just don't, I need it to have the new line because I'm trying to make it have a particular aesthetic. New paragraphs are not done with //. New paragraphs are 2 blank lines returned twice. So actually a blank empty line that looks in your source code file like a blank empty line, that says new paragraph. Okay? I can start new lines every time I want. In fact, the writing style in my lab is what we call 1 sentence per line. This actually makes multiple people editing the document better because Git, as a source code editor, treats lines as its basic unit of editing. So if I have 1 giant paragraph as a line, anyone edits this line and somebody else edits that line, there'll be a git conflict which causes merge problem, which is just annoying. So if we make one sentence per line, I can edit one sentence, you can edit another sentence, and it doesn't break anything. So,
Overleaf allows sharing. Overleaf allows sharing.
oh yeah, overleaf makes sharing easy. You just all go and edit at the same time. So, if you can see it on the screen. Now, the one thing that I have had some difficulties with, sharing with overleaf with a net where one of the two people has a significant network delay is painful. Because you can get some conflicts, and every now and then it'll basically say out of sync, restart.
Yeah.
Which is really annoying when you have a bunch of stuff in your buffer and now you're the one who's out of sync, right? So you can lose a little bit that way.
Control A and put it into a text document and refresh and try to figure out.
Yeah, so that's what it's going to get. So if it does give you that, you can sort of screen cut some stuff and hope to save some of it, but that's the best you can do. And if you work on a very unstable network, like when I'm trying to drive up to the mountains, right, I won't work in shared LaTeX. It's just too annoying. So I push it into Git, do my work, and then merge later. So everything in tech is based on boxes and glue. If you ever read the tech book, they talk all about it. It's pretty complicated. Tech does a really good job, but it's confusing to people in the beginning, especially when it comes to figures. Tech's rules for how to put figures are based on publishing rules, which generally try and put figures at the top of the next available page, which is more space efficient and actually aesthetically generally pretty good, right? If you try and put it here, it doesn't always work. So you'll have to understand how to play with that. Quotes in LaTeX use a different character to start and a different character to end, and they're both pairs of single quotes. The double quote character does not do what you want it to do inside LaTeX. And you'll find when you cut things and paste from Word or whatever, that's sometimes a problem. As I mentioned, the slash. There's a bunch of special characters like slash, dollar, brace, parentheses. You can't be written alone. They're all escaped using the escape character backslash. So if I want to put a $ in, I would say slash dollar sign. If I want to go percentage slash percent. Some things, organizations, I can have a quote, I can have section, subsection, subsection, right? LaTeX is, you don't want to say one period and call section 1, right? You want to do things with these labels because different styles, if I want to do ACM versus IEEE versus SPIE, they all have different styles. LaTeX knows about those, so you want to use here is what I mean it to mean. It's the beginning of a section, beginning of a subsection, beginning of the next section. Use the structure, which allows it to do stuff. It has multiple list environments, enumerate, itemize, and there's various packages that will affect the layout of lists. So if you want to change how it's the spacing or whatever, there are ways of doing all of that. In graphics, it's pretty simple. Use package for graphics. There's actually about a dozen graphics packages, but graphics actually is enough to get you going. So then I can include a packet, I can include a file by saying include graphics. Square brackets here mean what? Optional argument, they don't have to be there, but this way I'm saying make its width 50% and 50% of its file width. Generally a bad idea, I don't know what this file width is, but I think it's a file named .png. In my view, better are to specify things about how you want it to look in your file. So if I do include graphics, width equals 0.9 column width. The 0.9 is literally a multiplier. If I put two numbers next to each other inside a tech command, it multiplies them. So column width is how wide is my column. This says give me 90% of the column width. And that means my figure scaled. And if I change from a single column format to a double column format, it automatically scales everything. If I really want to be pedantic, I can say, no, the width is 3.1 inches. 3.1 inches, right? I can use, there's a bunch of things I can do. In fact, in general, I can do things where I have a bunch of value attribute pairs that I put before the file. LaTeX can do things in the include graphics package where I can use PNG, GIF, PDF, EPS, PS, and I can even do things like crop parts of the figures. If I have a multi-page PDF document, I can say go to page 3, choose the top 2 inches, going in 4 inches, and it'll crop everything out. Right? So this makes it easy if depending on what I'm trying to import. It also sometimes is confusing. If you use a text editor, not a text editor, a graphics editor, and you, for example, modify a PDF file, for those of you who are using Macs, if you edit a PDF file in Preview, change it and save it. Preview actually kept the original version and the new version. And if you import them into LaTeX simply, you will probably get the original version no matter how much editing you do, and it's very confusing for a while. So know that you need to export it as a PDF to flatten all the layers, or you need to use the LaTeX command to get to the layer you want. I've had a student who went crazy with this, and he's like, can you fix this for me? He's like, sure. Send it to me, it's like, oh, I see the problem, we'll just fix that up. So it takes a little bit. Boxes, as I said, everything's based on box. Every character in LaTeX is a box. It can be a little bit confusing. There's an area called a bounding box, and so inside your graphics file, you can actually say, here's how big I want the bounding box to be. You can mess with things like that. There's a whole bunch of things I can specify: width, height, aspect ratio. I can change the aspect ratio. I can scale it. I can actually rotate it at an angle if I want. I can trim it. I can clip it. If you want to know all the attributes, just Google them for the package. There's tons of things you can do to keep your graphics. And this is one of the reasons why, like, people's like, well, I edit it by hand, right? You can edit it by hand, but if it's generated by a program, so let's say you make a PDF that comes out of Matplotlib, you can get it to save as a PDF, but you didn't like the margin. Well, I can edit it by hand and crop out the margin, or I can figure out what that margin is and make my code in LaTeX crop out the piece I want, so that the next time I generate the figure, I don't have to re-edit it every time, right? So you can make that. That's why these things become useful. So, simple example, just to sort of show you this, given our time, I'm just going to push through. Example, some code that generates it. I can choose things. One of the things I didn't mention is if I really want a particular font size, there are commands in LaTeX that let me choose the font size. Oddly enough, it takes multiple arguments. And that you can read through the font size command, you'll see why. And you can sort of mix things together. Crop the image out a little bit by simply going in and saying what to crop. As I said, LaTeX has a very powerful set of floats. In general, I recommend you go with the flow, but sometimes it's annoying. The easiest way to change where a figure shows up in LaTeX is to literally take the figure command and move it around, and then it'll float it to the top of the right appropriate page. But sometimes you really want the figure to be here, even if it adds space or whatever. So this says put it at the top, and if not, put it here. And it'll do a calculation to figure out what's best for it. If I really don't want to put it at the top, I can say put it here, and I mean it with an exclamation point. And if I really want to make it stronger, I can mess with the glue, and I can say capital H exclamation point. So figures can be placed here, top, bottom, all on a page by themselves. Exclamation point says override some parameters that LaTeX thinks the result will not look good, and it'll try. Sometimes if your figures are too big, literally for even a page, right, and I forgot to scale them, then LaTeX will float them until the very end of the document and give up and say, well, it's the best I can do, I'll put them here. Generally, that just means you forgot to scale them properly, but you fix that out. LaTeX does everything you're going to work on in terms of things in terms of labels, right? You don't want to ever refer to equation 1. You refer to equation ref Einstein, where that's the label I put for things. So this way, if I add a new equation, everything happens automatically. Word has had this kind of feature for years, cross-references and whatever. Very few people actually use it. They still type numbers in by rank. Just learn to use the proper reference to sections and stuff, because sooner or later you will change a new section, you'll add a new equation, it just breaks. So you would put in a /label. Label actually goes to any environment that has a number. Equation, section, subsection, figure, table. For figures and tables, the number occurs, actually this is a tabular environment, I'll get to the table in a second. Tabular environments lets me put stuff in blocks. Tabular is where there are tabs and space stuff out. I can say how to align things, so I can say right and left, and this actually says right with left with a vertical bar in between them. And then I can have a line, horizontal line, do some stuff, add a new line. This is one of the few places where I actually say add a new line. It's like I'm done my line. Some new things. I can actually have things that put lines between only pieces instead of whole lines. And the tabular environment is very powerful, and you can set stuff up. When I go to play with a table, tables float around. They have a caption, a centering, a table, and then a label. The label needs to be after the caption. Tabular can be before or after the caption, it doesn't really matter. And whether or not the caption shows up before or after the table does not depend on where I put the word caption. It depends on the style's placement of the table, of the caption. So people say, oh, I wanted the caption before it. Put it before it. It doesn't matter. It depends on the style. Ideally, you want to generate code so that you can update them from any new run. So you might actually have something that looks like this, some document, some section with some theory, begin tabular that says, here's how I'm going to format it. I may or may not, normally in the way I do stuff, we don't actually, we put the table headers with formatting ourselves, and then we use a command inside of LaTeX called CSV read that will read a CSV file and treat those as the numbers separated as the columns for my data. So now this will read it in, right? And I'm going to specify that my line looks like CSV column I, CSV column II, and CSV column VI. I've taken columns 1, 2, and 4 and even skipped a column, right? And it'll take care of all of that. And then if I need to regenerate my code, well, it's just okay, I got some table, right? I got an easy table where if it's just an easy table, I can just do auto tabular. If the table has section headings, or column headings, and then a bunch of columns, it'll just read the whole table in, right? So that's really easy. If I want to do more complicated ones, then I can do that as well, right? So this is why I said it's good to generate your tables and stuff by code and then import them in LaTeX, because LaTeX makes it really easy. You rerun an experiment, rerun the table, everything's automatic. If you're having really difficulty with a table, there's a website called tablegenerator.com that will generate the LaTeX for your table. So in fact, what I recommend is if you're struggling with how to get a table to look the way you want, go to Table Generator, get it to generate the LaTeX code you want, copy the code, and then stop using Table Generator and import stuff the way you want. But now you know what are this weird spacings, right? You start getting the complicated tables, you might not realize how you want to look to make it look. So, math mode in LaTeX, the most important part for lots of stuff when Canoe started was how to do math right. So 3 plus 1 in normal mode will not look like 3 plus 1 in math mode. Math mode has separate rules for spacing, separate fonts. The traditional font, Computer Modern Roman, is being replaced, but and when you go to do things, it understands that certain letters in math have a canonical meaning. So the spacing between $F, X, Y, close parenthesis, will not look like that in italics. Even though italics is the closest font, it doesn't look the same because it knows that F parentheses is a function operator. So it has a little more space, where X and Y are arguments, so they can pull together a little bit. And it knows what to do with exponents and some complicated stuff. I can do equations in much more complicated ways, where I can have numbered equations or unnumbered equations. So I can do a lot. White space is pretty much ignored, so no matter what I do, $signs inside, it will eat all the space between things. Space is useful to separate different symbols, but to make it readable for you, but it's going to eat all of them. There are a bunch of specialized spacing commands, /, semicolon, / comma, and / space, / quad, / there's a whole bunch, but you can play with them, but those are the small ones. If I want to have text in math mode, I can use text IT or text RM or text BF, so that I can have my font. So here you can actually sort of see the spacing. Here is in math mode, my space fun.or italics my fame, right? Notice the spacing between the M, the Y, the F, and the U is very different in math mode than in italics mode. And it just looks funky if you don't get it right. So math mode will do a bunch of stuff. Most math is built in. The AMS math package makes it easier to do a whole bunch of stuff. You want any funky symbols, they exist. If you're not sure, just Google, how do I make lambda in LaTeX, and it'll show you the command is lambda, right? Or pi, or these get tricky if you don't know the name of nabla, or the real number lines. You say, how do I make a real number symbol in LaTeX? And it'll tell you, Google will tell you. So there's a whole bunch of those things. It can do complicated sums, infinity, whatever. There's a whole bunch more where you can find this. Whole tables of all the various symbols you can look at. This is useful when it's like, I need a new symbol, what do I do? You go look at this table, it's like, oh, I've never used new, I'll use new, right? Oh, look, I'll use xi, right? A few of them have symbols that are, pretty common, so don't make theta equal to something that, will really confuse people. Like, I'm going to use the letter pi, and what it really means is the number 0, right? That would just mess with people, right? Or something weird. Whole bunch of other math operators, even more math operators, a few more math operators, really good math stuff, right? A few more, some delimiters, some other contractions. So it can do all kinds of accents. It can do things like arrows and squiggles and over braces and square roots over various sizes of symbols. So, right, that can be very powerful as you're trying to put stuff together, hats and quotes and whatever. You type an equation in, just as an example, you can get in a very small amount of space pretty nice looking equations. A number of websites now use what's called MathJax, which is actually a LaTeX version made for doing some web stuff. If I need lists of equations, I can put together a whole bunch of equations into one long list. Begin an equation array, and then I have multiple equations where the ampersands cause things to line up, and you get some nice looking equations so that I can align them up on the equal, even though there's different sizes of stuff on both sides. Obviously, I'm not trying to get you to do this, right? You can go back and refer to it. I can refer to equation labels. I can label each piece of an equation array separately so I can refer to it later. I can do nice code blocks, what are called algorithms. So I can have a various algorithm thing that when implemented in your code, I'm sure you've seen some of these in papers, right? Little blocks of code to make it reasonable. There's at least half a dozen, maybe more, nice styles for coding depending on what you're trying to look like. So I can make it look in all kinds of different ways.
How did you make that line in the algorithm?
That line? That's because it says while, open brace to end brace. So it says this is a while block. The line goes from while to end. Right? There's no end while, right? The block statement together. And that's part of this package called algorithms that says here's the style of doing this algorithm. Right?
Is the while a keyword?
So it says /while, so that means while is a keyword for that. Right? That package defined a bunch of new macros like EF, while, K data, set line. There's a whole bunch of things you can do. So all these algorithms packages will have their own set of things to do. So this one's different. This one has like arg style, start, keyword, keyword style, stop, start. So very generic stuff. Some are more structured than others. Give me time. A few more things. So debugging LaTeX. When LaTeX gives you an error, and if you run it in Overleaf, the errors show up in a little button where it shows you there's like a red button, red thing will show up. It's showing you two things. It's telling you a line number in your source code file. It shows you what it was processing on that line, until it gets to an error, and then it shows the rest of the line. That's how you know what it was complaining about, right? This, and then the error says undefined control sequence because this person said today's date is Tuesday, Todi, right, as opposed to today, right? Dyslexic, I just misspelled it. So it'll just complain. In shared LaTeX, you can click on a button, it'll often take you to where you are. A couple things about LaTeX commands. In LaTeX, you define a new command by saying new command / my name and then whatever you want it to be. I actually recommend you use your own macros all the time. If you have some symbol in your paper you want to refer to, like my system name, right? My recommendation is you use the command, my name, my system name. This way, if later on you want to change it, you can. If you want to do things with it. Now, the one bad thing about using a command like / my name is if on my paper I said, and in blank space we did this, instead I said, in our paper / my name space we did this, the / my space will eat the space after it, which is a little bit annoying. But you can fix all that. And then there's some comments. There's some def is a tech, not a LaTeX command. I can have commands that take arguments. We routinely make commands in our papers to simplify and make our things more consistent. So like for figures and captions, you can do a bunch of stuff. I just want you to see them in case you're so there. I'm going to skip over these, LaTeX and PowerPoint. BibTeX. So BibTeX is what you're going to use for your references. BibTeX is its own type of file. So in this file, we have a citation. We cite in LaTeX by saying /cite and the name of a symbol. The symbol shows up, it's just like, and similarly, every time we had an equation or a label, they all show up in the file.aux. That's what the auxiliary file is for. When you compile LaTeX, the first time it will complain these aren't found. You compile it a second time, it rereads the aux, now it knows what it means, and it'll say found. Sometimes it'll take 3 times. When I compile the document with a citation, it might need a second or a third pass depending on how I do with LaTeX, with BibTeX. So our makefile, for the simplest version of our makefile, it is PDF LaTeX, and we actually say don't stop. The paper, run BibTeX on the paper, and then run LaTeX twice more, and then we can clean stuff up more. So if this was the citation. Now this doesn't actually have a separate file, it just has the bibliography. My recommendation is you just have a reference style and it'll take care of that. And it can then import stuff. Importantly, when I say /cite, in the bib item, there's a reference here. In the citation file, that style of doing stuff is actually quickly sort of broken. Well, this one didn't format very well, but at the very top of this it says /article and then something. The thing that shows right after that squiggly brace, that is the label for a reference. This is so bad, let's just fix it. That was bad. So this is a standard bibliography reference, article, and then Hemmendinger 07, and then a bunch of these fields. Now, if you're using Zotero, if you're importing from BibTeX, from Google Scholar, it'll generally have them pretty good. I do find that lots of Google Scholar references are missing some fields, but it'll do okay. The article says what type it is, that's the reference. So when I go to cite it, I would say /cite Hemmendinger 07. To make a BibTeX for the process, you create a BibTeX file, you get a BibTeX BST file, which is a style, and put that in the same directory. And then you run BibTeX on your LaTeX file, you run LaTeX, and then you get your PDF or DVI, right? So if you're doing this in Overleaf, it will take care of BibTeX and all the processing for you. If you're doing it locally, you have to have those things on your own. BibTeX can handle tons of file types. Anything else I want to hear? I was trying to see if there's anything else I want to get to. Okay, no, so because we're out of time, we'll call it there today. So your assignment for the next week is already posted, which is to basically make your first LaTeX file, figure out how to get LaTeX running on your own system. I actually do encourage you, even if you want to use Overleaf, figure out how to get it to run locally as well, because sooner or later you might fail and you don't want to always be on the web. And next class I will talk about Git and how to get stuff in Git. So I'll change the assignment. There's no Git assignment for this week, because some of you have not used it before. We'll get you to Git next week. Any questions? Okay? Oh, go ahead. Heather? No, go ahead.
In the one of the requirements it asks for a link. Do you want your PDF generated to actually link when you click on it, or do you just want a URL?
Actually, the link was for the
GitHub. I already
GitHub
added
stuff.
you. I've already made the repository, so like
yeah,
it's
so
on
that's
there.
fine. Yeah, so
Okay.
so I need some way to see it. So I will
Okay.
actually send some instructions so that if you do it in Overleaf, here's how you send it. You can actually just upload the PDF, right? There's a lot to do. You got to find references. You got to write this right. So for next week, you'll just upload the PDF as the assignment, and that's good. I'll tell you to upload two things: LaTeX source, PDF, so I can sort of see both pieces. Okay. Any other questions? So how did people find today's pace?